Hello viewers, welcome to my channel Learn Electrical Engineering 121 Pod.
Hello viewers, in the last session we have seen finding the transfer function of armature control DC motor. In today's session we will see electrical analogous of mechanical systems. In simple sense, we are trying to find electrical equivalent systems for mechanical system. Okay, now you can convert because differential equations are identical. If you are talking about electrical system or a mechanical system, you can convert from electrical system to a mechanical or a mechanical system to an electrical system. But then you have different types of conversions for this. Now for example, regarding the input and output, for example, if you are talking about mechanical systems, say you do have force as the input where output is x, say displacement, and in another system, rotational system, you have torque as the input where angular displacement is the output. Now if you go for an electrical system, then you have voltage as the input or else current source as the input. So you have different forms, like in electrical system you have two types depending upon the inputs. Likewise you have two types of system depending upon the inputs, force and torque. Now we'll see what are the equivalent parameters when you're talking about two systems. Now in this you have different conversions. Now for example, say you have force voltage analogy, like input is the force in mechanical system where input is the voltage in electrical system. Force current analogy, force in mechanical system whereas input is current source in electrical system. Likewise you do have torque if you're talking about rotational system, torque voltage analogy and torque current analogy. In translation system, force; in rotational system, torque. So you have four sorts of conversion depending upon the type of system. Now let's see the first combination, force voltage analogy here. Now in a mechanical system where the input is force, say, then in an electrical system the input is nothing but voltage. Here in mechanical system the output is, say, velocity, that is nothing but dependent variable, say velocity for example, or else you can also take it as displacement. In electrical system it would be current or charge. The frictional coefficient dash pot B. The dissipative element R here, resistance, mass in mechanical system, that is the storage element, inductance L, the spring, stiffness of the spring K is nothing but inverse of capacitance, that is nothing but 1 by C. You will be applying the Newton's second law, sum of the force is equal to 0 there, and here you are applying KVL here. So these are the equivalent parameters here if you are talking about force voltage analogy. Now we'll see force current analogy here. That means where current is the input. If force is the input in mechanical system, now the current source being the input for electrical system C. Now the output would be here, for output would be displacement here or the velocity. The output is voltage here, or else the displacement you can take it as flux here. The element B dash pot is equivalent to conductance here, that's nothing but G 1 by R, and for mass that is nothing but C capacitance, and for K 1 by L. Here sum of the force is equal to 0. Here we are applying KCL here. Now if you are talking about these two, then it is force voltage. If you are talking about these two, then you're talking about force current analogy. Now, we'll see torque voltage analogy here and torque current analogy. Here nothing will change here. Only the thing is, in terms of translation system, force is the input. Here torque is the input here for rotational system. The output is nothing but velocity or displacement, say, then that is angular velocity, or else x is the displacement, then in terms of rotational that is theta. For B dash pot is the same thing, dash pot here, rotational frictional coefficient here, and mass, the storage element, is represented by moment of inertia J, and K, stiffness of the spring, is the same here. Okay. Now, if you're talking about torque voltage analogy, torque is equivalent to voltage here, velocity is equivalent to current here, or theta, angular displacement, equal to charge here, B equal to R, resistance, moment of inertia J equal to inductance, and K equal to 1 by C. If you're talking about torque current, then you're supposed to remember these two. Torque represents current as the input, angular velocity, V voltage, theta with flux, B with 1 by R, J moment of inertia with C, and K with 1 by L. So if you remember this table, if you can memorize this, it would be easy for you to present or do the problems regarding this analogous system. If you do have any queries and suggestions, please comment in the comment section below.
Thank you for watching. If you find this video helpful, please like, share and subscribe. Stay tuned for more videos.